This video will go through the 4 steps of a hypothesis testing process with broad strokes. We haven't yet introduced p-value, which will happen soon. For now, we're still using the 2 standard deviation method or the 5% rule to make our conclusions. In this example, it reads, does Mr. Young have more than 80% support from registered voters? A random sample of 114 registered voters is collected, and 95 out of 114 support Mr. Young in this sample. So the first step of the hypothesis testing process is to write the null hypothesis and the alternative hypothesis. And here they are. Recall, the null hypothesis needs to have the equal sign, so it reads that pi is equal to 0.8. 80% of all voters will vote for Mr. Young. Alternative hypothesis needs to have a less than or a greater than or a not equal to sign, and so this one would read more than 80% of all voters will vote for Mr. Young. We selected more than because that is what the research question read in the very first line. Step 2 of the hypothesis testing process is to collect a sample, hopefully a representative sample from the population, and calculate the sample statistic from that sample we collected. We were told that a sample was collected and that in that sample they found 95 people out of 114 supported Mr. Young. So 95 out of 114 is the proportion of the sample that supports Mr. Young. That's a p-hat. So our p-hat is 0.833 approximately. So 83.3% of our observed sample supports Mr. Young. Step 3 says we should create a distribution of sample statistics based on the idea that we assume the null hypothesis is true. So our first step here is that we assume that 80% of all voters support Mr. Young in the population of all voters. In other words, we assume that pi is equal to 0.8. We don't actually know if that's true or not, remember. We're just making a guess. We're making an assumption. Now that we've made that guess, we've made that assumption, we'll now build a distribution of simulated sample statistics based on that assumption. So I open up the one proportion applet in Rossmann Chance applets. The probability of heads, we put 0.8. When I press enter, it changes it to probability of success pi, which is 0.8. We're assuming pi is 0.8. The sample size, our sample was 114 people from the population. I'm going to create a simulated distribution of 1,000 sample statistics. I hide the spinners. Draw the samples. There is our roughly normally shaped distribution. We could go ahead and switch that to proportion of successes. And we can also click Summary Stats, so it will display the mean of my simulated distribution, which is very close to 0.8, right at the center. It's 0.798. And it tells me that the standard deviation of this distribution, which is also called the standard error, is 0.037. I'm going to take a quick screenshot and insert that into my answers. All right, so I'm still in step 3 here. I created a distribution of sample statistics. We notice that it's centered at around 0.8, which was our assumed value of the population proportion. It tells us that it's actually at 0.798 because this is a simulation, it's not perfect. It tells me that the standard deviation of this distribution is 0.037. So if I go up 1 standard deviation, I'll start at 0.798 and go up 0.037 units, and I land at 0.835. If I go up another standard deviation, so I'm adding another 0.037 units, I land at 0.872. That's 2 standard deviations above the population proportion, the mean of the distribution. We could also go down 2 standard deviations, so minus 1 standard deviation and minus another standard deviation to see what is unusual on the other side. And if you do that, you get 0.761, which is 1 standard deviation lower, and 0.724, which is 2 standard deviations lower. So I now have a sense of what's considered unusual. If we collected a sample of 114 individuals and our sample statistic was higher than 0.872, so 87.2% support for Mr. Young, that would be unusually high. And if we went out and collected a sample of 114 registered voters and found that less than 72.4% of them supported Mr. Young, that would be unusually low. This is all assuming that it's true that 79.8% of the population supports Mr. Young. Lastly, then, is step 4. Step 4 is to make a conclusion, and the way we do that is we locate our observed sample statistic on this distribution of sample statistics, and then make a conclusion based on that. Our observed sample statistic was 83.3%, was our p-hat. 83.3% is about right here. That is not unusual. It's not higher than 0.872, which is that realm of unusually high statistics. So I conclude that our sample statistic is usual expected sort of statistic to get. It's not in the unusual realm according to the 2 standard deviation rule. Now, since we have a usual expected sort of statistic within this distribution of sample statistics, we conclude that the null hypothesis is plausible. In contextual terms, that means it is plausible that Mr. Young has 80% support from the registered voters.